Hi everyone. Today I'm going to present the overview of photobioreactors that include the principle of design, mechanisms of cultivation, limitation, and advantages. So there, it is this the presentation of outlines. Firstly, in the introduction, there are various techniques for microalgae cultivation that have been reported. The cultivation method is minorly influenced by the strain type, source of nutrition, and investment cost. It can be classified into main categories that are closed system and open system. So in open system photobioreactors, uh, as we know, as the widest system used in the algal growth for the large scale, and there are many types of open system photobioreactors. So I will discuss the simple pond and stirred pond and raceway ponds. So they have traditionally been used to cultivate microalgae because to their low cost, as well it is simple to process and low energy consumption. So the first type of open system photobioreactor is unstirred pond. The simplest open system for microalgae cultivation is the unstirred ponds. Unstirred ponds are built in natural water system with depth of half meter. It provides it provides an economic and convenient way for microalgae cultivation. The second one is the raceway pond. This cultivation method has been used extensively in open system cultivation and also for large scale commercial production algae. The mixing in this configuration is induced by paddle whales to ensure algae cells are suspended within the culture medium. The third one is circular band. Circle bands are differed from the innovation of wastewater treatment bands that consist of a circular reactor with a rotating arm located at center. These bands usually have depth in the range of 20 to 30 centimeter or 30 to 70 centimeter, and the diameter is between 40 to 50 centimeter. The mixing in this design is done by a rotating arm moving in axial direction. So here we have the advantages and the limitations for every type of photobioreactor in open system, and they almost have the same. We can see the common limitations and advantages. So in closed system, we have the five types, or actually four types of photobioreactors in closed system. So we have the vertical and tubular and stirred tank, as well as the flat panel. So the purpose from design of closed system is to overcome the hardest of open system. In closed system, the conditions of microalgae cultivation are controllable within high value productivity. The first one of the closed system photobioreactor is the horizontal tube photobioreactor. So we have here some terms. The long tubes, the horizontal tube, also known as tubular reactor, is the first constructed model of closed reactor for microalgae cultivation. For the area and diameter of tube, this setup requires a large area of land due to high surface area required. In this type of reactor, the culture medium is circulated within the tubes together with exposure to the light sources. The second one, we have the vertical tube photobioreactors. And for the vertical tube photobioreactors, we have two types. The first type in the top is bubble column, and the second one is the airlift reactor. So the bubble column reactor resembles a cylindrical shaped vessel with no internal structure. Will be the fluid pattern flow is minorly driven by the air bubbles generated. The similar features for both types of photobioreactor are that they have an air spurger. Typically, the reactor height is twice its diameter. So for airlift reactor, it features two interconnection zones. We have two interconnection zones, a riser zone and a downcomer zone. In this configuration setup, the process is called airlift. due to the air bubbles driving the liquid from the riser zone within the constructed tube to the illuminated zone. The third one is the stirred tank photobioreactors. So the concept of tank design basically is coming from the fermentation tank design. The concepts are similar, while the difference that can be distinguished from microalgae cultivation are the need for the additional external light sources. As well, we have the agitator. For this reactor, mixing of the calcium medium is aided by the mechanical movement of the agitator that also ensure optimal heat and mass transfer. It has been reported that stirred tank express shows good performance as it provides very good mixing and transfer. The last one is the flat panel photobioreactors. We have the air asperger that generated bubbles and that are supplied to the pump that are mixing and circulating the culture medium. The mechanisms would potentially enhance the microalgae biomass productivity, increasing the maximum or the mixing rate and providing appropriate amounts of carbon dioxide. So also we can see this the alpha angle. They can be positioned vertically or inclined at certain angles to receive maximum light intensity from the sun or light source. Flat panel system benefits are in providing high surface area to volume ratio for illumination, flexible design for scale up process, and low amount of oxygen accumulation. Here we have some the features and limitations for every type of photobioreactors in closed system. For example, in flat panel, it is high illumination surface area, as we mentioned, and the limitation is scale-up process required many support materials. For bubble column, for example, high mass transfer due to spring. As well, we have here, for example, in tubular, the mass transfer can be improved by installing internal mixer. So we have many advantages and limitation for every type of photobioreactor enclosed system. As well, we have here some microalgae that have been cultivated in photobioreactor with different capacity in each one. So for example, in flat panel, we have Cholera vulgaris with a capacity 1.5 and the concentration of biomass is 27 milligram to 45 milligram per liter per hour. For example, also we have in bubble column Manudis. So in Manudis, with the capacity in the bubble column is 64, and the concentration of biomass for Manudis is between 0.03 to 0.2 gram per liter. Last one, for example, we have the left column. We have Hematococcus blavirus with the capacity is 3, and the concentration of biomass is 4.06 gram per liter. So we have here some the parameter that should be taken in consideration for design on both open and closed system. For example, we have the light utilization, and open is low and closed system is high. The controllability, temperature, light intensity, mixing rate is low in open system, and the closed system is high. As well, in for example, shear stress, we have in open system is low due to gentle mixing, but in closed system high due to turbulent flow and pumping through gas exchange. As well, we have the for example operating cost. It is we can see cheap in open system and is expensive in closed system. Conclusion, photobioreactors have a various design and mechanisms that affect on microalgae cultivation. Therefore, many factors should be taken into consideration to choose the suitable photobioreactor, such as the type of microalgae strain, the mode of growth, and the medium of cultivation. We can see that closed system can be tuned to operate more efficiently, but open system remain more popular due to the lower cost and high productivity. The main issue with open system is, is the system being harder to control to obtain the optimum productivity. Many, many of the parameters we looked at in detail as they play a major role along with the cultivation methods to ensure the success of algal growth. This is the references, and thank you.